In this video, we're going to be executing the code that's provided in the module. So first of all, go to Google Colab, open up a cell, copy paste the code, and we will run it by clicking on the play button. But before we run it, let's take a look at the code real quick. I'm not asking you to understand everything that's happening in this code, but let's take a quick look. This section where it says import, that means it's just trying to get all the needed libraries set up for the code to run properly. So like if it needs to do some math functions or draw some graphs and things like that, it will need to get those libraries all set. So where it says import, then means it's getting all the libraries for you. And that's the first step. You will see in all Python codes this section where it imports all the libraries that it needs. So just think of it as simple as that. You need some libraries before it can execute a code. So that's what it's doing. Step 2, it's going to create 1,000 random data records with the transactions, bank transactions. So basically what we're trying to do with this code is we're going to train a model to determine whether a transaction was a valid transaction or it was a fraudulent transaction. And so we're going to ask the code to randomly create 1,000 transactions, and then with 4 different features. So each transaction will have some random sort of ranges of these features. So for example, the first one is the amount of the transaction from 500 tenge to 50,000 tenge. So a record will have how much money was transacted, what time it happened, and then where did it happen? Was it far from your home? Was it like 2 kilometers from your home address or 20,000 kilometers from your home address? If it is a 20,000 kilometers from your home address, unless you're traveling internationally, it would be a little bit weird, right? And then the second feature is the hour of the day. What time did it happen? Did it happen at 3 p.m. or 3 a.m.? If it happened at 3 a.m., unless you are traveling somewhere in a different time zone, it would be weird, right? So, and what's the fourth feature? Is this a new device? Were you using your typical regular device that you've been using all the time, or did you just register a brand new device that the bank never seen before? Something like that. So it's a typical transaction, but it's going to create 1,000 of them with random numbers in these 4 features. And then it's going to split the transactions out of 1,000 of them. 20%, you remember the 80% and 20% rule? We're going to use the 80% of the data to train and then 20% for testing. So 800 of them will be used for training, and then 20%, which is 200 of them, will be used for testing. So we split the data out of 1,000 transactions. So step 4, this section will actually train the model, and then the next step is test the model. And then after that, it will show the results. Step 6 is confusion matrix visualization. This topic will come several more times throughout the program, so you will see it again and again. And let's take a look and see what kind of a graphs it will create, and also business impact based on what the AI model has found. It's going to calculate, was it serious damage to the reputation? For example, if your AI model incorrectly labeled valid transaction as a fraudulent transactions, then your customers will get really upset because, hey, I used my credit card at 3 p.m. at a grocery store 2 kilometers from my home address, and the transaction got declined. Why did it get declined? If that happens a lot, you'll be very upset, and then you say, "Oh, I'm done with this bank. I'm going to switch to a different bank." Right? That could happen if you treat the innocent customers as fraudulent thieves. Right? Also, if you miss some of the fraudulent transactions and you did not label them as fraudulent, if you just label them as valid transactions, then the bank will lose money, right? So all these things will be shown in graphs, and then it will show you if there was any business impact. Okay, so I try to run the code for the first time. It didn't. I see the issue here. The first line, that's the name of the code here. So I'll just put the sharp there to make this first line comment line. And then let me run it again. True positive means that it was actually a fraudulent transaction, and the AI model labeled them as true positive fraudulent transactions. So they caught these false transactions, and so the bank did not lose money. So remember the 80-20 rule? We used 800 of transactions to train the model and 200 transactions to test. So out of 200, 161 were turned out to be true negative, and then 10 transactions turned out to be true positive. So they're good ones. Okay, now let's look at 6 false positives. Means that 6 people out of 200 customers, 6 people were trying to do some valid, transactions, and then they were declined or rejected because bank thought that they were fraudulent. And so these 6 people must be very angry with the bank. Hey, I tried to use this credit card, debit card, and it didn't go through. Why? And so they will be questioning the bank. Now, 23 false negatives means that there were 23 transactions that went through, although they should not have gone through. So bank must have lost some money in that regard. So that's what it means. So now you see that how the 200 transactions were classified, and then so that gives you an idea. I think it's a pretty good model in my opinion. But let's look at the graph on the right, which shows the accuracy, precision, recall, and F1 score. So accuracy is very important, obviously. In this case, it's 85.5% accurate. But what does that mean? Did you get the right answers? Yes, you got the right answers. That's a pretty good rate, 85.5% of the time. You got it right. But you got it right because maybe you had good customers. You had good customers with a true, valid transactions, so the accuracy was good. What if you started with 100 of those customers were not your customers and they were fraudulent transactions? They were making fraudulent transactions. Obviously the accuracy will be coming down drastically, and so that's what accuracy means, whether the determination was the right choice or not. The precision is also very important, because are you sure they were fraudulent transactions if you labeled any of the transactions as a fraudulent? If accuracy is bad, then you will have a lot more of false alarms, and then it will annoy a lot of innocent customers who are making valid transactions. So recall, what does that mean? The thieves escape? Did they take the money out and run? And then did you catch them? Or did you catch them or not? That's what it means. If you do not catch them, obviously you will lose money. And so that's what it means. And the F1 score. What F1 score It means it's a balance. If you have too strict rules or too many questions you're asking for each transaction, then you may have a lot of the false positives. And then when you have a lot of false positives, that means a lot more people will be very upset and they will switch to a different bank. At the same time, if you have a lot of false negatives, the bank will be suffering a lot because of loss of money. And so if F score is high, that means it's a good balanced. It's not, the rules are not too strict so that it does not annoy too many people. And then the rules are not too low standards so that a lot of fraudulent transactions could take place. If you have a good balance, that means not too many false positives, not too many false negatives as well. And so the higher these scores are, the better your AI model is. In real world, the F score will not be like 90%. It's just it will be very rare case if you see something like that. But if F score is somewhere 40-50%, that's pretty good F score. That means it's a pretty good balance. Accuracy, definitely you must have, probably if you're a real bank, you want to have a higher accuracy and then higher precision and a higher percentage of recall so that you catch all the thieves that you're supposed to. So it kind of gives you an idea how AI model could be trained to classify different transactions and cases. And then it could be different industry with different data sets. But if you are classifying something, you definitely will be dealing with true negatives and true positives and false positives and false negatives, accuracy, precision, and recall and F1 score if you are classifying something. And so these things will come up again if you are classifying something. So hopefully you got the basics of what these terms mean in this exercise. And then hopefully you'll remember accuracy, precision, recall, and F1 score, what they mean. And so you cannot just say, hey, we have a good accuracy score, but if the precision is low, then it's not good, right? And then if F score is really low, your AI model is not so good either. So hopefully that you will remember when you're examining an AI model, you will remember these terms and be able to tell whether your AI model is really well trained with a good data set and it's showing all healthy numbers. So hopefully you picked up something out of this and then you will use it when you are training and designing AI models in the future. So thank you for your attention here, and then I'll see you in the next video.